If parallel universes collided, not with fireworks, but with data, the first sign wouldn't be spectacle. It would be instruments quietly disagreeing. This is a systems question: measurement, logistics, energy, finance, and people, strained by a new kind of interference. No apocalypse, no science fiction, just the practical mess of two near-identical realities brushing past each other. We define collision as temporary cross-correlation between two nearly identical physical states, not matter mixing, but information overlap. In practice, that looks like correlated noise spikes across distant sensors, as if a second dataset partially imprints on the first. We stay inside tested physics: measurement, decoherence, signal processing, error budgets. Nothing violates conservation laws. Global arrays, seismometers, GPS stations, magnetometers, particle detectors are ideal to catch synchronized anomalies. Every system has a baseline: drift, jitter, downtime. If a collision happens, the baselines deform together in ways models can't fit. Time is the glue. If anomalies align to UTC across continents, it moves from local fault to global hypothesis. We establish the baselines now, because the next minutes get technical, and details decide what breaks and what keeps running. Metrology labs see fractional frequency offsets, parts in 1014, coordinated across sites, too correlated for random drift. GPS issue logs show simultaneous integrity flags, not a satellite fault, not ionospheric weather. Timing layers disagree. Data centers apply step corrections more often. Millisecond hiccups break some microservices, recoverable but noisy. Exchanges note out-of-order ticks at the microsecond level. Market data firms widen time window reconciliation to keep order books sane. Seismometers show weak, identical pseudo-events, no physical quake signature, appearing as correlated noise at the same UTC second. Magnetometers log small, synchronous excursions inconsistent with solar activity models, hinting at an external, non-solar pattern injection. Background counts drift by a fraction of a sigma in multiple labs, independently boring, jointly suspicious. Weather stations report synchronized one-tick pressure kinks, too subtle to feel, too synchronized to ignore. Air traffic control widens separation buffers by a mile when GPS timing flags amber, adding minutes to congested hubs. Electric grids see tiny ACE deviations. Automatic generation control holds, but operators tighten deadbands to resist cascade risk. Payment rails extend settlement windows by seconds. It looks conservative, but it prevents rare double-post reconciliation errors. Multi-region consensus tolerates small clock smear. SLOs dip, uptime holds. Engineers write blameless postmortems. Media explains, timing irregularities, experts investigating. Calm, because flights still land and lights stay on. Preprints propose cross-reality correlation as a data fit, not metaphysics. Peer review proceeds on methods, not headlines. Cloud providers post status notes, time sync under heightened monitoring. Users carry on. Initial consequence: baselines move, not broken, recalibrated. The story shifts from detection to adaptation. Argo floats show tiny synchronous spikes in thermistor readings. Telemetered updates reconcile, but data assimilation flags anomalies. Ensemble weather models widen, spread by a fraction, reacting to correlated noise. Forecast skill dips marginally, then re-optimized. AQ monitors register aligned outliers. Kalman filters tag them with lower weights. Monthly trends remain stable. River gauges auto-flag correlated jumps. Water managers keep release schedules. Alarms retuned for pattern-aware filtering. IoT pings from containers show timestamp bunching. ETAs slip by minutes. Dispatchers add small buffers to truck slots. Price feeds handle micro-reordering. Volatility nudges up, mostly from humans reacting to ambiguity more than from mechanics. Factories adjust takt time by fractions of a second. SPC windows widen. Throughput holds within weekly targets. Insurers price a small uncertainty surcharge on latency-sensitive risks. Premiums nudge. Portfolios stay diversified. PMUs show tiny angle mismatches across interconnects. Operators rely more on local state estimators than cross-tie phasers. Carriers increase syncy reliance and holdover modes. SLAs remain, with a fine print footnote on global anomalies. Databases favor logical clocks over wall time more aggressively. Fewer clock-based leases, more vector clock reconciliation. Autonomous systems tighten sensor fusion gates. If two frames disagree, they degrade gracefully to human-supervised modes. Orbital operations rely on onboard clocks and celestial fixes. Ground correlation issues are fenced off with better ephemeris hygiene. Networked monitors log out-of-order packets. Systems cache readings locally and reconcile, preserving clinical workflows. Labs teach anomaly literacy. Students learn how to tag, wait, and not overreact to synchronized noise. Explanations stick. No, physics didn't break. Yes, metrics shifted. People adjust expectations like they do for time zones. Standards bodies add annexes, correlated anomaly handling. Auditors gain a checklist for cross-reality events, dry and useful. Utilities, telcos, finance, and aviation run a joint drill. Lesson 1. Keep local control loops independent when clocks wobble. Security teams separate anomaly signatures from intrusion patterns. Correlation is global, attack footprints are not. A consortium aggregates raw time series worldwide with common schemas, enabling robust, open anomaly studies. With coordination and boring discipline, the world treats the collision like weather, monitored, budgeted, and manageable. People make jokes about being late in the other universe. Sarcasm is a coping mechanism. Schedules still run. The best scientists are boring on purpose. Careful language, qualified claims, reproducible methods, incremental fixes. Playbooks add a page. When UTC-aligned anomalies hit, slow down automatic retries, widen idempotency windows, monitor human load. After the initial wave, systems settle into a new equilibrium. Not perfect, just predictable enough to price, plan, and live with. Timekeeping shifts to multi-source consensus. GNSS, terrestrial LORAN-like beacons, and ensemble atomic clocks with voting logic. Apps prefer event time semantics, late data handling, and monotonic IDs. Wall time is for humans, not consistency. Grids invest in local inertia and microgrid islanding. Less reliance on distant phasers, more on local observability. Aircraft treat timing anomalies like GNSS outages. Inertial navigation, DME, and procedural spacing keep throughput acceptable. We learn the signature. Correlation strength rises and decays over hours. Geographically coherent, seasonally modulated. Overlap windows map to regions, not borders. Oceanic expanses show clean signals. Urban RF noise masks subtlety. Field test beds validate filters, holdover strategies, and human-in-the-loop thresholds. It's engineering, not mysticism. Conservative defaults lower incident rates. Teams that resisted clock magic tricks sleep better. Contracts specify timing tolerance windows and reconciliation procedures. Audits ask how systems behave when clocks shrug. Markets price a tiny uncertainty premium that fades as tooling improves. Boring is bullish. For most people, the collision becomes background radiation of modern life. Like leap seconds, noticed only when software stumbles. Scientists keep measuring, engineers keep hardening. If another overlap comes, the monitoring will catch it early, and the playbooks will open with practiced hands. If parallel universes ever collide as information, resilience looks like humility. Measure, doubt, adapt, repeat. What scenario should we explore next? Share your ideas below. You've been watching Ifverse, where imagination meets possibility. See you in our next reality.